like to begin from where I left off the other time. So we have this bulletin board application. Actually, maybe I should put the code on GitHub. So let me do also the boring things. So sorry, too many applications open. Actually, I want to start the screen sharing. I don't know what it means that I'm both screen sharing and presenting to everyone. I thought that was the default. Okay, so I go here so that you know how to do it. I don't think I have a bboard repository in the many ones I have. So let me create one. I call it CMPS 121 bboard Android, okay? Because there will be a bboard cloud as well that I will give to you later. But so I'm doing this so that right now, if you like, you can get the bboard code while I teach, okay? So this is not private, it's done with Git. I created a repository. I just want to show you the mechanics of how I do it for once in a while. I won't be doing it often, but once I do it. So now I created a repository on Bitbucket, which is currently my favorite. And here there are some instructions, okay? So now I do the following. I go to the command line, okay? I'm in my directory that is called Android Studio Projects, and I go into bboard, which is where my project resides. And because I copied it, this comes with the old Git repository of where I copied it from, and I really don't want to do that, okay? So what I do is essentially, I simply do remove recursively the Git directory, okay? Which kind of, deletes the previous, everything that is using Git is in this .git directory, and there is a file called .git/configure or configuration, one of the two, that contains the Git configuration. That is where the server is and whatever else, okay? So I think I could have done it in a more graceful way, but this is as good a way as any. Now I say git init, okay? I check that I have a git ignore file, and I do have it, and that's fine. I want to have a git ignore because I don't want to automatically, import all kind of binary stuff that Git would do otherwise. By the way, where does the git ignore file come from? It's because originally in Android Studio, I have clicked on that command that we initialize the version control system, and that is kind enough for you to create the right .git ignore for Android Studio projects. This seems like a detail, but it's actually a little bit of an annoyance to create the git ignore file, because you need to know essentially where this build system of Android Studio, which you may not know really well, decides to store all its temporary files. So it's very convenient to do it this way. Okay, so now I've initialized the repository. Now I tell it to add the current directory, and when you add a directory, it recursively adds all subdirectories. Okay, so I do this. And I say git commit -a, and I can say at the beginning of class 6. Okay, I don't know, whatever comment I may want to add. Okay, and this has created it. Then I go back to this window, and you see this is the magic line. So when you create a repository on your local laptop, it's a very good repository, actually. That's all you need if you want to version your code, say, for a homework. But if you want to push it to a server, you have to say which is the remote server that acts as the server, okay? So let me make it a little bit bigger so you can see better this line, okay? So, but this is the line I need to do to add origin pointing to git@bitbucket.org. So I copy this line, I go back here, I just give it this line, I guess, and then I do git push origin master. Okay. And this did it. Okay. So now if you want, you can go to look at the file CMPS 121 bboard Android, and you can get the same code I will be using. Okay. And there are many ways, but I show you one more thing. Actually, well, I cannot show it, but there is this program called Source3. Let me, hold on, I need to check on this. Okay. Okay, so yeah, we are always connected, right? But Source3 is one of the nice ways to actually visualize the branching, and is useful to you not so much if you do a homework in which you do many commits in a line, but if there are multiple contributors, if you want to figure out how they collaborate. Unfortunately, I don't think I have a Source3 window that I can show to you. Because okay, these I can show to you, but it's kind of boring because I think everything here moves in a linear line. Okay, but I recommend Source3. Actually, for the ones of you that are really, you know, how to say, what is the right adjective? You know, high-powered people. My belief is that GitK that was done originally by Torvalds and company is better, okay? But it's a pain to install if you're not on Linux. GitK is much more powerful. So what I really use when I do real work is GitK, because GitK allows me to do stuff that I cannot get done otherwise. For example, I can point to any two pieces of the repository, any two versions, say the check-in by you and the check-in by him, and it shows me exactly where they differ. Okay, so I can pick any two places and very easily ask for what's the difference between the two code bases. And I can also go examine directly without having to check out any past version of code, which is incredibly useful because sometimes I see, oh goodness, you know, this thing I erased it 5 revisions ago, but actually it was not such a bad idea. I had this couple of lines and then erased it. And then you can go rescue them, okay? But it's a pain to install if you're not in Linux. Okay, so Source3 is, let's say, the best friendly replacement I have found for it. At least it shows you the tree of revisions very nicely. Okay, so so this is it. Now, this said, okay, so of course in Source3 I have a lot of stuff, so let's close it. Great, this is done, and we can go back to developing. Actually, there are two things. This is my Android Studio bulletin board application, okay, which we haven't built very much yet, okay. And here is, here. No, I'm a bit lost, sorry. Here, too many windows I have. But here I have my application for the bboard for the server. So I think we can do various things, but at this point, I might as well put up this application on the cloud and show you very quickly how to test it in a very simple way. Okay, so because if this does not work, we will have pain developing the Android one. Okay, so you need to. One of the difficult things is to test these applications that talk to a server. So let's do it in a very simple way. Okay. So the first thing is that this is built for the Google Cloud, and I'll give you the code. So what I do is there are other ways to do it, but using the Google App Engine Launcher is an easy way to do it, because I have this, it enables me to click here, and this will deploy the app and put it in the cloud. So I may have already done it, okay, but let me do it again just in case, so I know that this happened. So you see, it's giving me a log, and the deployment was successful, and it's updating the apps. One of the reasons, I mean, there are a few reasons why I like App Engine. Let me list them a moment. I think one of them is that it's easy to deploy. If you have one app, if you have one machine running, but especially if you become a larger company and you have a lot of machines running, it's very nice to be able to deploy in a single blow and have your code and decode it to any number of front servers you have running, and change the code to all of them in a single blow. The other thing why I like it is that it has very easy way to check the log files of the server online. Okay, so it will be very easy to find if we make any mistake. Yeah, and the other reason is that, yeah, this has very little configuration for me to do, actually. So it sort of works really well for this type of classes. Okay, but let's try. Now, let me look at the code again with you a moment. this puts some data into this data store, okay? So I have an app ID, a key, and some data. No, sorry, we want to test post message and get message. So there is an app ID and a message, and we have to check that this works, okay? This is, I think, the fundamental one that we will need today. The other ones we can test as well, but you know, at least this post message, I want to be able to test it. So how do we do it? Well, it's actually not so hard, luckily for us. So, because I can take a window and then I can reason as follows. These, if you looked at the path of this application, it would be, let me show to you. This is in backing store, applications, store. So store is the name of the application, okay? And then there is this default controller, okay, that has this method inside that is called, sorry, I'm going around, that is called, how it is called? Oh, that is called post message. So I wanted to send it something. How do I send it something? I can do this. Curl, okay? Curl is like wget, is a command line based way to make calls. Actually, I may not need to use curl. I could use as a browser if you want. So you can type this in the window of a browser if you wanted, okay? I use curl just because, I don't know, why not? Because it's easier for me to rerun a previous line, I think. There is no other reason. Curl HTTPS. Now, the name of my app is, I forgot it, but if you forget it, is here. It's Luca Teaching, okay? So Luca Teaching, appspot.com. And then after this comes the name of the application, which is store. Somebody please help me if I get it wrong, okay? And then this is the default controller. And this is post message, okay? And at this point, I have to follow with the arguments. So app ID is equal to Luca, okay? And message is equal to be happy. I'm so lazy that I don't want to play around with the URL encoding and doing complicated things. So this is just completely for testing, okay? So I want to see whether I do this, whether it blows up or whether it actually works. And I have this incredibly unpleasant feeling, you know, that whenever I do this, it's like cringing that it will blow up. So a bit of startup time is normal. And then I get an error, okay? You see internal error ticket issued. So how do I test the error? And this will happen to you really when you do calls to these. So the way I test the error is that I do console developers google.com. I have this Luca Teaching. I look at the logs. And here I should find an error, yes. And I hope the error is small. Eh? Unable to store in file? Oi, oi. I'm sorry, this really puzzles me. Which line triggered it? Sorry, this is quite unexpected. In select row, items fetch page. What is it? Let me simplify this a moment. Okay, the basic technique in software. what did I call? I called post message. This is quite weird. Oh, no, sorry, I'm doing something stupid. Of course it would fail again if I don't upload again. Otherwise, I simplify it until it will work. For these, okay? Now, okay, be happy, be happy. So evidently, I had some mistake that I'm not gonna pay attention to now during the class, but I have some error here. It's the limit by that is not accepted by Google App Engine. Sorry?
There are two parentheses.
There are two parentheses, yes. One closes the limit by and the other closes select, right? Yes, now, but before it was not, right? I mean, before what I had was this, right? And these closes everything it opens, I think. So I'm semi-sure. Let me try. You know that it is the limit by that has some interaction with the Google storage. So let me try without putting a limit by. It will be good enough for this class, okay? But let me upload it again, and then we will solve the limit by clause in some other way. I don't know. We can always loop and just return the first results by hand, I guess, if that's what we want. Okay, but so now I put be very happy. Okay, so just to check, and no, it doesn't like it. Sorry, here. So there is something in this order by clause or in this other clause that is not liked, and I don't know what it is. Okay. I never said, yes, somebody's saying I never set the post date, and that's true. But if I look at the models here in the tables.py, I have that the post date has as default the current time. So it should be there. And the other thing that I can check on what is going on if you deploy your own app in the cloud is this, that you can go look at, you can go look at the cloud data store. Where is it? Here. And you can query it. Okay, and in this case, we can see all the data we have actually put in, so we can check whether the data is there or not. It's a bit slow. Okay, fine. And I want not these, but I want the B board. Okay, and so you see that the data is there and everything works, except that for some reason the query doesn't work. Now, I don't want to waste time on the query, but I want to solve it later because of two reasons. I'm using a new version of Web2Py for these, and I have a nagging suspicion that there is that they wrote from scratch again the adapter to the databases, and I don't think it's as well tested as the old one. So before I waste time in class, I want to contact the author of this database adapter between Web2Py and the Google App Engine and check with them that actually the bug is not on their end, so it's not the case that we waste time here. But at least you have seen how to get this done, okay? And if I want to at least return no more than 10 entries, I can do that very easily by saying something like this. Okay, so this is a list. Well, I would have to code it in a slightly different way, but for example, I don't know, the list is empty for what is it? Does this look reasonable to you? It's not incredibly prettily ran, but this will work, I think. No? Any mistake? No. Okay, fine. So this will return at most 10 rows. Let me put it up and test it one last time, and then we go back to Android development. Okay? Oh, this is nice. I don't need to authenticate each time anymore. They sort of improved it in the latest version. So the deployment is successful. I do one more curl, and then we are happy. Okay, and be very, very happy. Okay, what did I do? Sorry. Okay, so I do these. Okay, and I get a list the way I want. Okay, fine. Okay, great. This is good enough for the class. Okay. Now that I know that the server actually works, which is a prerequisite, let me come back to my Android app I was building with you. So let's see. We have this written this. So there was this submarine model in which we prepare the call, we do the call, and then when it comes back, we need to tell it what to do. Okay, so we wrote together these. Oh, I'm sorry for these pop-ups. We wrote together with post message spec that says what to do once the message comes back. Okay, and so far I'm not trying to do anything smart, but I'm just getting the result. I'm pasting it as it is. In a text field, okay? And I've told you that I built this JSON method here. So in fact, what I may be missing here to make the debugging easier is something like this. How it is called the logging? Because I always redefine it. Is called log in lowercase or log in uppercase? In uppercase, I guess. Log tag. Okay. So I want to log what I got. Then I de-JSONize it. So I translate it back from JSON into a Java object. Okay, that is a message list ML. Okay, and then this object ML is of type message list. Okay, we have here the type of message list. So this essentially is a type that contains many messages. So here I made my first mistake actually, because this is an object, right? And an object in Java looks like a list. I'm doing this because it's more general to JSONize it to an object. But an object is something that has a field. This field is called messages, okay? And then we have a string of a list, okay? Instead, what I'm returning from my web app incorrectly is just a list, and I cannot do this, okay? Because this will expect, this JSON here will expect something that says messages is equal to this, is equal to the list, right? Because here I have a field messages in the object, and that has as value a list, okay? So I'm returning essentially, I'm producing the wrong JSON in the cloud. Okay, and I could fix these in order to accept a list. It wouldn't be very hard actually, but it wouldn't be very general. And so to give you a better idea of how to do it in general, I actually prefer to fix the cloud, which is very easy. I go back to the cloud, and instead of returning here in post message response of JSON of L, I want to return a dictionary of messages is equal to L. This will build a message. I need one more. This will build a dictionary that will look like, you know, messages. Well, actually, I don't need to show you. I can upload it and show you. Okay, so and here also I would need to change it in dict of messages is equal to L if we ever happen to use these. Okay, so let me show you what this does once I upload it again. You see why it's very convenient to be able to deploy fast, because one needs to do it very often. Okay, so let me try it. Yeah, you see? Now this is a dictionary in which the messages is the tag, and then there is a list of strings as the type. So now this return type matches what I've declared in Android Studio here. Okay, now this matches. Before it didn't. So I'm always looking at Dustin, if you notice, because I find it very difficult to focus on code while I teach, and so I'm happy to get some confirmation that I'm not completely off. But if any of you notices errors in what I do, you know, speak up, because you know, I do make errors quite a bit. Now now everything should work, because ml.messages will be this list, and I can ask for the length and iterate over it, and everything should be fine as far as I know. Okay. Now, this is great. Now, did I already write the code that generates the call? Okay, so when I click on the button, let me reread the code of what we do. So first we get the text we want in message, okay? Then we start the call, so we build a my call specification, which is a new post message specification, okay? I set up the URL, I set up the context. This checkin.json is wrong, obviously, right? Now we know that the right call is, what is the server prefix? Store default. Okay, and so this is a post message. I can look here if it's correct. And I think that I'm adding a .json, and I think that's fine, actually. Even if I call it with a .json, this would work. Yeah, so I'm adding more and more happiness to it. Very good. So now the URL is correct. Then I need to add the parameters. Okay, so I build this hash map. I build a hash map just because it's very easy to build a hash map and add stuff to the hash map. And as a sort of a small additional benefit, building a hash map will ensure me that you know, the name of the variables are unique. So it's kind of convenient that we do it that way. And anyway, that's the way I set it up for you to be easy to use. So I build this hash map. I put my app ID and I put my message that I just got above. I set the and I say fine. Now in my call specification, set these parameters m that I just created, and this will you know, will do the job of taking the parameters, encoding them appropriately for an HTTP call. You need to encode stuff you are sending over for an HTTP call, right? You cannot send binary things. There are things you cannot send. So this URL encodes it in the appropriate way so that it won't get mangled during the call. And once you do this, I do the actual call, and I execute my call specification when this comes back. Okay, so and I don't know, as far as I know, all I can say is that I don't see any obvious error. Okay, and so at this point I don't have anything better to do than try to see whether it actually works or not. Yeah, it's always with a little bit of a cringe. Oh yeah, but if I do it this way, you won't see anything of what I do. Let me see if I can run it on an emulator first. I'm not quite sure it will work well, but let's see whether I can do that first. Otherwise, I use my phone. Yeah, I could use the dock cam, but it's always a little bit slow to shift from one to the other. So if I can do it with an emulator, I try, and otherwise I will. It's building. I don't know why it takes so long to build. Joy. Okay. This was just slow. Okay. I even get my phone in a usable size. Now I have to wait until it boots. Sometimes usually emulators would emulate less well, right? No. Okay. Okay, great. Hey. Okay. I think I have to say run again. And so I hope it does not bomb. Sorry? I launched another emulator. Oh no. Yes. You know, if it did it with my phone, I wouldn't mind it cloning it, but it always happens when you don't want it. Sorry. You would imagine that the obvious choice after you launch the emulator once would be to use the emulator you chose already, but fine. Sorry? Sorry? No, I think they do it because of fidelity, right? I mean, I think the emulator just has, the real Android code base inside it and does everything from boot to the rest. Because if you, in Android, by the way, while we wait for this to boot, you can also develop by using a native layer to your code. So you can also include the Linux code, I mean C or C++ code in your build. We will not be touching upon that in class, but you can do it. So for that, you have to use, I think it's called the NDK instead of the SDK. The NDK is the native development toolkit. And if you want to develop, for example, well, let me give you a classical example. OpenCV is this image processing package that is available for phones as well. There is a version for it that works under Android. OpenCV is written in C++, and it's written for Android using the NDK. And if you want, you can modify the C++ code base of OpenCV, writing your own. But this boots forever. I have to restart it. Yeah, but this is getting a bit long. Okay, so this is the last try. Otherwise, we use but it should work. I don't. Okay. So I was saying, and so you can also develop it natively. But this is I don't cover it in this class. Actually, to be honest, I've not done it so far. I kept to Java development. Okay, so now I need to run it again. Like, okay. 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 So I don't know if I can just type with the keyboard. Yes, so I can post a banana, as I always do. I'm cringing, okay? Because, I mean, what are our bets? We should do it with a clicker. Okay, so we have to take attendance, okay? So let's do it anyway to have a bit of fun. So let's say A is equal to it will work. B is equal to it will crash. It will crash less than 4 times, so 3 at most. C is equal, it will crash more than 3 times. Okay, so you can have your wager here, and we can see whether I do better or worse than what you think. Okay, so let's give it a actually, I think here we want to see this. That's pretty good. And if you look at the shape of the distribution, for those of you that know statistics, it looks like a gamma distribution. So if you have a random process in which you can either randomly add or subtract, or you can randomly move left or right, you get a Gaussian, right? But if you get a random process in which essentially the outcome is bound to be positive, the gamma distributions are the most common result. And in so E, D and D, what do they mean? You know, that they think that it will be so bad that you will throw tomatoes at me. Okay. Any more clicks? Let's stop it. This is my final result. Okay. I think, my own bet is B. I don't think it will, I mean, rarely things work on the first time. But so let's post it. And this does nothing. Okay, so E was the correct answer. Why doesn't this do anything? I'm afraid that this doesn't do anything because the networking of the phone is not connected in the way that it likes. But I may be wrong, okay? I don't know if this is my problem, actually. I don't think it may be. Oh, yes, Android HTTPN. I don't know that this is my error, actually. Okay, this is getting a little bit tedious. Well,
How do you check what's going on in the server itself?
whether we got the call, that's a good idea, actually. So let me go to the logs here of the server. Let's see if I get a log for bananas. What is this? Ooh, these are the people who are using the non-normal app for checking in. No, you see, I get a be very happy, but I don't get any banana. So it appears that the phone is not doing anything. Now, the most common cause for not doing anything is an error on my part in which the button is not tied to anything. So the app comes up incredibly happy and then does exactly nothing. Since this is such a good explanation, let me just check that it's not what is happening, okay? So I have here a method that is called click button, and I just want to check that I didn't do the very stupid error of not connecting it. No, it is connected. Sorry? Right. No, this was just a layout thing, so let me rerun it again just to be on the safe side.
Is it somehow, is there a debugger tool that lets you execute certain functions in your program while you're debugging it on an emulator or something?
Hold.
For example, if you want to call a very specific function while you're executing a program, you just type that in and you can see what happens.
No. You can set breakpoints, I think. Okay, but you cannot do that.
Can you show me what some of the good debugging tools are? Those are very useful.
Yes, but what I do is basically use logs and look at what the app is doing. I don't do anything complex in that sense. Or you can add breakpoints as well, I think, in the code, and you can examine the value of variables. So let me cancel this because this is already running. And nothing happens. So oh, but I'm so stupid. This is another app. I have more than one Android Studio open. No, this is my error. It's called attendance because I didn't change the name. I think that if I go in values strings, the app name is attendance. It should be bulletin board. So let's do this so we verify that we are running the right code. I set it to run again. We should at least see that the name on top changes. And then I want to try to see why this doesn't work. So, okay, so we're at least looking at the right screen. Come on. Okay, now I can say banana. I can post it, but nothing happens, okay? So, let me look here in activity main. On click is click button, and we are in the right app. Now, so if I go to main activity, in click button, oh, if last location is equal to null, return. This is the error. Sorry. Okay. I mean, come on, you have all the time to look at things without teaching. You should be telling me what I get wrong. So I have to wait, until this reloads. Okay. I mean, the hardest errors to find are the stupidest, right? Because it's easy to think of logical things that go wrong, but it's it's hard to think of. Okay. But I did the call, but I got no messages back. Okay. You see, everything works except that I receive an empty string. I receive a string that says that there are no messages, which is correct. Why is it correct? Because I changed the FID. Now the FID is Luca, so let's not be fooled, right? The FID is Luca. It was not Luca before. It was something else, I think, for the command line. Let's verify before I'm taken by something like this. No, the FID was Luca, but here the FID is something else, I think. What is the FID is Luca bboard. Okay, so it's normal. Now let me go on the cloud and verify if I actually got the data. Well, actually, I can see the log here if there is any. Okay, you can see that now there are various logs. Okay, but okay, it's most uninteresting, this log. I don't log enough things. Okay, I should log the variables, but I'm essentially reaching it. But if I go to the data store and I look at what I have inside in my bboard, I now have Luca bboard. There is at least one banana and there are perhaps more, okay? So now this explains part of the puzzle, but why the other part of the puzzle? So so let me add banana and potatoes. Okay, okay. Now I get stuff. Why wasn't I getting stuff before? I don't quite know actually. Like milkshake. I think I know what's going on. Is anyone else using this app from the command line by any chance? Yeah. Okay, thank you. No, I mean, it's good. You're checking that that essentially it works. So can I ask, is it true that somebody was using it for the command line? Yes, right? No, you can say there's nothing bad. I just want to tell you one piece of information that is useful. Yes, right? Okay, can I have confirmation? I see smiling faces. Yeah. Yeah. This is very good, actually, that you did. But I want to explain why the first result was empty, because it's unfortunately something that is a bit peculiar to App Engine and not to a normal database. So the story of App Engine is this. It uses this Google Data Store. The Google Data Store is given to have a very high bandwidth. Okay, you can push to it an enormous amount of information per second, and you can also pull out of it an enormous amount per second. So if you want to implement one of these huge companies, think at, I don't know, Snapchat, or which is based on App Engine, or, we are doing based on App Engine a startup that processes images, so we have to throw in it like a gazillion images per second. So it has very high bandwidth, right? But to achieve this high bandwidth, it does not have a database that sits in one place like MySQL. It has this data that is spread around many servers, so that when you put the data, you don't always talk to the same server, but otherwise it become, a bottleneck. So when you write data to the Google Data Store, it essentially does something like this. It says, "Ooh, a new piece of data. Okay, let me find out which server to send it." And it sort of decides according to some semi-random rule where to put it. Okay, then it puts it into the place where the data belongs. And the data write works like this. First, the data is written. Once the data is written, the indices are updated. Okay? So first the data is written and the call returns. And then in the background, the indices are updated. And this is done in order to give you a higher bandwidth. Okay? Because updating the indices is harder, it has some correlation. And so it's done in the background for you, and you don't see the mess that it actually takes. The drawback of it is this, that if you insert some data that has a certain FID, like FID is Super Banana, and then you search for Super Bananas as FID, the data with the Super Banana you just inserted is not going to be indexed yet. The indexing itself may take 1 to 3 seconds. I mean, sometimes it takes a tenth of a second. But there is no guarantee. It may take up to 5-6 seconds. Okay. Typically, my observation is that it takes around a second. But this means that if you put something in and you retrieve it immediately by looking it up in the index, you are not going to find it. Okay? So this means that we have this very nasty problem in this app, that if we add a message, we are very likely not to find it back. Okay? So if, for example, let's see whether this is true. Now I add an apricot. Okay? Let's see whether it's back in the list of things once I do it. No, you see it's not there. But if I add an apricot with chili, well, this time it's there. So I don't quite know why. Where is my apricot though? Oh, I see the problem. I'm reading stuff in random order as well. I'm keeping the first 10. Okay, so there is a bit of that effect. But so one of the annoying things of using the data store is this: that if you write to it and you retrieve the data immediately, you are likely not to find what you just inserted. So your phone will have to remember it and add it to the end. Okay. So this is maybe at some point I should teach you a technique to avoid this mechanism, to avoid this problem. I don't know if I should do it now or if I should do it after the you know, in a later class. I want to spend some time in a later class, I think, to talk about strategies to synchronize the information on the phone with information in the cloud. Actually, maybe I should do a poll whether we want to listen to it now while we are doing this, so you want me to fix the app while we are doing it, or if you want me to get to the list view. So now, actually, I would like to do my classical break in the middle. Let me, before the break, let me just do this poll. Open this poll so that you can vote. Sorry, not this way. This way is like A, talk more about sync, and B is equal to continue implementing the list view. And the list view is the nice way to display a list of messages in this case, or a list of items. Okay, so that's what I want to do next. So you can vote on these. And in the meantime, there is a break, and also there is but before the break there is an announcement. Please.
So we just got MSI for second for this class. Luke asked me to wait till the break. We can have one. How many of you guys haven't heard of MSI before? Like everyone has, right? Well, but maybe you haven't. Anyway, so it's MSI is showing that it's pretty great. Does with regular attendance, so it's encouraged you guys to attend frequently. I posted times up on the board in class so that people, as they walk in, can see it and they would write it down. I don't know if you guys in the back can see it. It's sort of small and a little screen is casting you a shadow on it. Couldn't have been what seen. Anyway, I did this class a year ago. I got an A in class. This is one of my favorite subjects actually. So I really hope to see some of you guys at my section. Starting this week, so the first one you guys could actually come to is tomorrow, the 12:31 section. We also have one section 2 to 3, ground to 1, and now we're using the Android Studio rather than
Maybe you should talk about synchronization analysis.
Yeah.
No, I'm gonna give some other strategies. I'm going to Okay, small break and then yeah, and then I get to decide, I guess. Dai.
Yes. Hi, so for the homework that was due last week, I zipped my folder with WinRAR instead of just using the regular zip, and some people weren't able to open it because I honestly just assumed everyone had WinRAR.
Yeah,
but I guess that's not the case.
No, because a lot of people have like Linux stuff
I mean, I won't do that in the future, but 2 people didn't grade mine, and 2 people did. So,
but the grades that you got are favorable.
I thought the people who actually did grade it gave me fair grades, but the other 2 people just didn't grade
But
it
then
at
you
all.
don't need to worry at all.
Okay, so I'll be okay.
Yeah,
Okay.
yeah. The votes, I mean, that's why it's the possibility of
Yes, I mean, yeah, who did grade mine? They gave me a 10. Should I talk to?
no, because there is a way to decline which doesn't give a grade.
Right.
That's different.
So, as a typical
Yeah. Yes, that's fine. Yeah.
like, oh, it doesn't have an 18 grams. Like, yeah, it does. You just don't.
Yeah, yours is like.
Anymore. Oh, no worries. Embarrassing, but you see, it's red, this log. This means that it's not imported. And I think in the code, somewhere in the edit, you have some option to fix the imports. You know, but I have this option that may be convenient for you to use. If you go into the settings in the editor, okay, there is some place on the imports called auto imports. Show import pop-up, add an ambiguous imports on the fly. This will be very useful for you, okay? So now you can say okay, and you see this log turned on, okay? And now it will work. It's because here at the top of the file, you don't pay attention to it, but because it's done automatically, but there are these things. And now log is imported, but before it was not. Okay, so if you see stuff right, I mean, if you hover on it, it would have told you undefined symbol, but it's undefined because you don't import. Okay.
Okay.
That's fine. You can register when you come once in a time, and it's retroactive, so it's fine. I need to run the update this afternoon, but it's retroactive, so it will be okay. I'll post today, so it shouldn't be no problem.
Just got a quick question. It's like just bugging me a little bit. So I found that under that name here, this is how NO Studio recognizes the name of your project, like when you open a page, right? And under strings here, there's a string name after it. And so I changed it to HW1 dialer, right?
Yeah.
But it doesn't actually do anything.
Okay, can we look at it later though, because I want to begin again. Okay.
Oh, there is.
Okay, so I will do a compromise essentially. That is, I want to tell you a little bit about synchronization with the server without necessarily doing it, because to do it would take me a little bit of time, but I want to tell you the principles. And then I want to go on to give you as time will permit. Okay? So, essentially, there is this problem. When you talk to a server, or when you have two things that talk together, this is useful much beyond Android, actually. There's a general problem between distributed systems. So when you talk to a server, you have two choices. You can either talk about change or you can talk about state. For example, I can either say, post this message, or I can say, this is the list of messages that I've written, okay? Or to give another example, suppose I write a refund app so that when I go on travel for my job, say, I can, enter that I spent, $5 for a sandwich, and this will tell to the server, hey, Lucas spent $5 more for a sandwich, right? Or, this is the change approach. And then there is the state approach, in which you say, hey, this is Lucas' list of expenses in the last month. The phone would say to the server, and the server says, hey, this is the list I think Lucas spent. You compare the two lists, and you fill in the missing items on either side, right? So, and this is true, by the way, also in automotive systems. No, if you are building a car control system, you don't know it, but cars have super sophisticated control systems. Maybe you know it, but they have like dozens of processors on the car. And so there are two ways. One is to say, hey, I'm starting to accelerate. And the other one is the acceleration now is at 0.27. And you press a little bit more, but essentially the accelerator pedal continually broadcasts the acceleration setting. Now this goes into the computer of the car, obviously. No? But there are these two paradigms. And essentially the fact is that with very few exceptions, it's much better to communicate state than change. Okay? This is especially true for mobile phones, where you risk losing messages so much. The problem is this, that there is no good way, and now I want to give you the sort of teaser explanation so that you know why this is a very general result. But there is no very good way to communicate change in a reliable way. Okay? So if I want to communicate Lucas spent $5 more, so the problem is this, that both my phone and the server have to agree, they have to reach a consensus that Lucas spent those $5 more. And they have to count it once and only once. Okay? And this is essentially impossible to solve. And so also the posting message problem, the only thing you can do is that, in the end you can say, hey, fine, Luca wanted to post this message, but I forgot about it and it's fine. And Luca will realize that the message is not posted or it's not posted, and the world is not going to end here. So this is one possible approach. And frankly, often this is taken. But the best approach is to try to communicate state. So first I tell you how I would do it to communicate state, even though I will not implement it here. Maybe I should give it to you to implement as homework. Maybe that would be a very good homework. But if I want to implement state, I will do the following. Whenever I post a message, okay, I give it a random ID, like a big random number, okay?
And so that's the idea of the message. And then I tell to the server, this is, you don't communicate state since, the beginning of time. But you may keep on the phone the list of messages that are less than 1 week old, say. Okay? And then you tell to the server each time, these are the messages Luca posted in the last week, or in the last day. I don't know. It's up to you how long it may. But each one has an ID and a message. The server then compares whether it has all of them. It writes the ones that are missing, and then it replies to the client, whatever it has to reply. Like, it still does we need to find the latest messages and send it to the phone. If you do it in this way, there is no double posting problem, okay? The phone, of course, then takes the merge. The server will give back to the phone. So the messages will transit in this format, okay? There will be an ID, and there will be a message. And the trick of using random IDs is very powerful because it means it's very unlikely that that you generate twice the same ID, but yet you don't need to remember the list of all IDs you have ever generated. Git works in the same way. It assigns a big random ID to each commit you do, and it does it in such a way that it does not need to know all the commits that everybody working in the project is doing. Git wouldn't be possibly able to know it because you can work when you are offline, right? And so, randomness is a very big, gift. So essentially, when you talk to the server, you get a list of ID message, ID message, ID message. So we would just add an ID field to our database. Okay, that's why I don't want to do it. I want to tell you how it is done, but not do it. So you would send to the server this list of ID and messages of the latest messages in the last week, whatever. Okay, maybe each message would have also a timestamp. Okay. And then when the server gets back to the list, before you display the messages, you would say, okay, these are the messages I want. These are the messages the server gives me. Now I can smoothly merge them because if they have the same ID, then they have the same message and they should be presented to the user twice. So if I write I love apples, and the server, and I tell it to the server, and the server comes back with a list of messages that doesn't include my I love apples, I'm able to merge it and still show it to the user because I wrote it. But if the server already includes it, I know that it's a repetition because the two IDs match, and then I include it only once in the list of things that are displayed, right? So if you communicate change, this is a much safer way. Another example that that people like to implement games as projects. So suppose we implement how it is called naval battleship. This game in which you shoot like A4 and you can sink the other person's boats, right? A simple solution would be to say, now I'm the phone and I send A4 and to his phone, and then his phone replies, etc. But then if I lose a message from him, then suddenly my belief and his belief start to diverge and would not be brought back together. Since the checkerboard of naval battleship is small, I think a better strategy would be that each time I send not my move, but the state of my board, in which there can be W for water, if I shot and missed, H for hit, something like this. So that when I send it to him, he knows all that I'm supposed to know, and he can check the whole consistency. So that if one of my shots gets missed somehow, at the next one, if it's applied, he will get actually both set of shots. So I would design the game of battleship in such a way that I would set up the configuration, something like the configuration of my board and the information on who's turning to do the next shot. Okay, something like this. This makes these things much harder to grade. Okay, and okay, are there questions at this point? Trick of random IDs and using IDs to turn change into state. For the receipt app, what would I do? Well, there, I could use random IDs, but I don't really need to because the system can spend money at a finite speed. I can, attach a timestamp, and so the ID can be simply look at ucsc.edu, my user account essentially, plus the timestamp of the expense, and that's a unique ID for as much as it needs, right? And so each time my phone would send to the server the list of my expenses with a date. If you have ever worked as a consultant, that's what you do when you reconcile the invoices you get with the payments you did or you received, right? there is this is for me at least, because I'm a messy person, is the bane of accounting, that I have always, you know, multiple lists of the money that went in and out due to some consulting or some thing, and then you know, I have no clue whether everything was paid or how much, and so you have to reconcile it going by date essentially, you know, and the fund would do the same in that aspect. Okay, so this is the constructive part of the speech. That is how to make sure that you send information and you receive it back, keeping it consistent. The destructive part of the speech is the following, sort of, to show that it is impossible to reach consensus between a phone and a server, but the result is more general. So the problem is this. There are two things that in this case I like to think of them as two people, just because it makes it more vivid, okay? So these are two friends. I will call them Ada and Bob for A and B now. Like these are classical names in cryptography, I guess. So there is Ada and Bob that have to decide, let's say, whether to go to the movies or not. And they either both want to go to the movie or they both want to stay home, but they want to reach consensus. So they want to leave their home knowing whether they're gonna both be there or they're gonna both stay at their homes, okay? So this is like the phone and the server trying to essentially reach consensus on, you know, whether I did spend this more $5, yes or no, okay? And the problem is this, that you're talking on an asynchronous medium in which there is no known upper bound to the delay of messages, okay? Which is actually, with a very good approximation, what happens on phones, you know? Messages can be lost, messages can be lost, and you basically don't have much information about that, okay? So this is the idea between Ada and Bob, that instead of giving each other a phone call, which is a more synchronous medium of communication, I don't know, they go to the neighborhood kid and they say, hey, you know, bring this message to her, here is $1. But you don't know whether the kid, you know, will actually go to her and deliver the message, or the kid will instead, you know, I don't know, go to the candy store, meet some friends, and go around the city, you know, and your message will never be delivered. Okay, something like that. So, I mean, this message loss is very, very common in the kind of networks that you communicate on in the internet, right? So, what is the consensus problem? The consensus problem is an algorithm. So, the algorithm creates consensus if this happens. These people can think at 0, 1, or 0 or 1. Okay? This is 0 stay home and 1 goes to the movies. And the consensus algorithm has to have these properties. One is that when it commits and it decides that consensus is reached, you have to be sure that that both people believe the same thing. That they, you know, they have communicated the same, and they have reached the same consensus. That it's going to be either 0 or 1 consensus. You don't care how it is done, but they have to have the same consensus. This is one property. The other property is that the consensus has to match at least the opinion of one of the participants. Okay? Because otherwise they tell you a stupid consensus protocol. Stay home. You know, maybe both wanted to go to the movie, but my protocol says stay home. And then you reach consensus in 0 messages. Okay? But that's not what you want. You want the consensus choice to be the original choice of one of the participants. Otherwise, the problem is not well answered. Okay? So suppose we want a consensus protocol that has these two properties. Both people agree, and they agree with what one of the two originally wanted. Okay? Which seems to be the basics. So can you do this? And the answer is no. There is no way you can do it. The proof is very nice because it's very simple. The proof is as follows. Imagine that, you know, if you have these two people, and you start by saying, hey, I like this Bob. Hey, you know, one, I really want to go to the movies. And then Bob tells Ada, thank you, I see your message, let's go. Right? So you give the act back. And then at this point, what does Ada think? You know, Ada may think, well, now Bob knows that I want to go to the movie, and he replied he wants to go, but he doesn't know whether I got the answer, right? Because this message could be lost. So at this point, Bob has replied to me that he's willing to go to the movies, but he has no information on whether I actually got a reply back. So Bob is undecided. So let's help him out by telling him, oh yes, thank you, I got your acknowledgement, right? Can I stop here? No, I can't, right? Because at this point, Bob thinks, well, you know, Ada knows that I told her that I want to go to the movies. And I got her reply that she got my reply, but she doesn't know that I got this message. So at this point, she doesn't know that that I've been taken out of my limbo. Even still in limbo, and she doesn't know that I'm out of the limbo yet. So I have to send one more acknowledgement. And so you may need a protocol in which you may do very complicated things. You imagine that you have a protocol that at some point says, you concatenate all the previous messages, you sprinkle salt over them, and crash them into a signature and send it back, and you do all this incredible stuff. And so imagine that this is a by contradiction. So imagine that there is some crazy way in which you do this protocol well enough, such that when the protocol terminates, let's say here, both have reached consensus. So once you are here, there is this magic situation that is called consensus, in which both people agree truly that one is going to be the choice. But essentially they need consensus. Suppose that by contradiction you arrive, you can devise a way to send enough back and forth acknowledgements so that at the end of it both people are sure, yes, I'm going to go to the movie, and I know that Ada is going to go to the movie as well, and we have both know that this is the consensus we reached for the evening. So why did we know a contradiction? Because the proof is done like this. Notice at this point that both Ada and Bob have committed to consensus. Okay? The problem is that this message may have gone lost. Okay? This message here may have gone lost. And as far as Ada is concerned, whether this message exists arrived or not, she cannot tell the difference. Right? Okay, no? She cannot tell the difference because there is no acknowledgement back. So for her, the situation in which this message is lost or is received is the same. So if here Bob at the end of this protocol has committed to consensus 1-1, it means that Ada have already committed. So it means that at this point, as far as Ada is concerned, they are sure that they are both going to go to the movies. Okay? Now, a moment. Now you go one step back and you say, wait a moment. Think about Bob here. Bob here is about to send the message. And if Bob sends the message, if the message is received, then Ada will commit to consensus. Okay? So Bob is there, has this message in the hands, and says, okay, if I send this message the other way, and Ada receives it by any chance, she will commit to consensus. But I don't know whether the message will be received or not. No? I mean, I send it, but it may be received or not, but both this or that can go missing. So I will not know whether the message will be made. Okay? So, because we have, once we reach consensus, we both have to agree. If my sending the message causes the other person to go into consensus, I need to go into consensus before I choose to send it. There is no other way around. Okay? This is a crucial induction step. Okay? Because Ada will need to commit here to consensus, and my message will need her to commit. I need to commit to consensus before I send the message. Otherwise, there can be the situation in which one of the two is in believes that there is consensus on something, but the other one does not because it's still waiting for an answer, which is not what the algorithm is about. Okay? So if you do this, you can go back more and more steps. And I think at this point you can guess that essentially you get by contradiction that the consensus should have existed even before you started running the algorithm, which is not possible. Yes.
Well, just that in a Computer Engineering 107, probably one of the things we're talking about is networks. And in any kind of a network, when you're sending a message, you also have to, what's done today is that there's always a protocol by which the receiver sends a message back saying, I got it.
Yes.
Is that what we need to do here?
No, that doesn't work. I mean, that kind of works in the sense that, and so, this is exactly what the reason I showed you the proof. Because there is always this belief, but if I do it well enough and I send enough acknowledgements back, in the end I do it. But even in the networking protocols, you don't have this certainty. Even if you
try to write stuff to a database like TCP/IP. You know, I tell you, please write this, and then the ACK doesn't come back. Okay, now what do I do? I tell you to write it again, but if I tell you to write it again, you might have already written it once. No?
How do I know that you didn't actually receive it? You received the confirmation, and it's just my fault that I didn't receive the confirmation.
Exactly, I mean, it goes on like this. And so, you know, usually this is hidden, because it's hidden by the fact that the current networks are extremely reliable, and people try to talk by state. So if I tell you to insert something, I don't know, the databases generally will try to, you know, complete the insert sending back. But there is always the off chance that something goes awry, and, you know, that you make a network call and the acknowledgement packet is lost, and you try to minimize that probability. And in the end, what you can do is you can make the probability very small. So in the end, you know, we can all be hit by a meteorite or have more, you know, usual disasters happen to us. So maybe it's not important. But in principle, if things can get lost, you cannot reach consensus in this way. So if you look at what networking algorithms do, it's very similar down to sending state. Because how does a real networking algorithm work if you look at under the hood? It does not only send an acknowledgement and feedback, but these messages over TCP/IP have sequence numbers. Okay, and you look at the sequence numbers and they're placed in the transmit window. So essentially, what the two servers are communicating over a TCP/IP connection is not really, you know, give us one more packet, oh, thank you for the more packet, give me one more packet, thank you for the more packet. If you look at what they do in networking, essentially, the TCP/IP connection works like this. You are sending many packets, okay, and so you start sending them, and you have a transmit window of how many packets you can have sent that are not acknowledged yet. The width of this transmit window determines directly the speed of the connection, okay? Because every packet takes, say, 10 milliseconds. So if you can have 10 packets outstanding, it means you can send the 10 every 10 milliseconds or 100 milliseconds. If you can have only 5 outstanding packets, it means that your speed is only 5 packets every 10 milliseconds, so there's no half the speed. So the TCP/IP networking protocols regulate the speed by the width of the transmission window of the non-acknowledged packets that can be passed. And every packet has a sequence number, and when you send these packets, the other guy is going to send you some acknowledgements back, and you know, maybe this is acknowledged, and then you can move your window off by 1. And this is not, this may be acknowledged, this may be acknowledged, and once this is also acknowledged, then you can move the window that starts to read, and so on and so on. And so if you take the network class, which I highly recommend, you can see how the width of the window determines the speed of transmission. There is this multiplicative increase, additive increase and multiplicative decrease that keeps the people participating nicely, and yada yada, and so on and so forth. But you have to see that by adding sequence numbers and playing with the transmission windows, even at the network layer, in the end, what they do is precisely the thing of transmitting state. Because they add a unique ID to each packet and they wait for that to be acknowledged, exactly as I was telling you to do with a list of receipts. If you weren't doing this, you would be in bigger trouble. Yes?
I had a question. Like mobile phones that you really like keeping active, or just like didn't have to actually wait for like receive like confirmation package and don't have like access to like certain variables. Like for instance, like a mobile app that's like an online game or and like two people acting at the same time.
So
How would that look on like
I'm saying you look at an app where multiple apps where people can play and say so maybe it's not.
oh, I mean like if there was like no confirmation, like it wasn't just like Emerson the person like a message and then they received a message, they send me a message. It's just like they don't have access.
I mean, you know, if you don't care about consensus, you can do a lot of things. So for example, you know, suppose I do an app in which the more I push on the screen, the higher this bird flaps, but the bird is flapping on your screen and then pushing on my screen. And maybe I don't care about reaching consensus, right? It's okay if some of my screen pushes doesn't leave the happy bird flying there, and you know that's gonna be fine, I guess. So not always you need consensus.
Okay, so so it's your choice, but in a, like a battleship game, you would need consensus on whether the ship is sunk or not.
Okay, so what if battleship is in real time? They just like call out.
Well, in real time, I think I would still use my solution of sending state, because the state of a battleship board is going to be what, 120 bytes if you encode it, and so that's so minimal that I wouldn't care. Basically, when you do when you do a network call on an Android, you know, most of the time is not spent transmitting the individual bytes. Most of the time there is a DNS domain name server call to get the address, the address of the destination if you don't have it cached already. And then there is some time to set up the TCP/IP call to the server that says, hey, look, I'm gonna do now a call to this. Yes, you can do it. This thing, you know, and then you start the call. So this overhead is the dominant part. You know, then sending, well, it depends on how long the call is, but there is no, if you're under a kilobyte, there is basically not very much dependency on the size of the message on modern networks. There was a,
So this, it seems like there could be a problem if you have too much data to send in a reasonable amount of time. Is there some sort of protocol where you can have the necessary stuff? Or?
yeah, you can get the state, but really my impression is that people overestimate how hard it is to send data. I mean, okay, fine, if you're sending entire photographs, so this may be bad, right? But if all you're sending is post of messages, this thing, you know, the main cost is setting up the connection. It's not really to send the actual content. So you know, in many cases, it doesn't matter so much. Okay. Okay. Well, you know, time is almost over, so we do the list view the next time. But I think it was or I hope it was.
Timeout system like video networking, where if it times out, you could send like a triple hack to have one send the last message. I mean, there were many solutions. I mean, I took a networking class last year. One is obviously sequence numbers, and two is if like timeout went